In this video, we're going to find the area of the region bounded by the graphs of the parabola y squared equals 2x plus 6 and the line y equals 2x minus 1. First, let's graph the graphs of these two functions and see what the region is. Then we'll proceed to find the area using the definite integral. First, the line is easy to graph when x is 0, y equals minus 1, so it's over here somewhere. And when y is 0, x equals 1, that's the second point on the line. So just connecting these 2 points, we get the line y equals x minus 1. Now, parabola, right over here, can be solved for x. 2x equals y squared minus 6. Dividing by 2x equals to 1/2 y squared minus 3. Now this is a parabola that opens to the right. Its vertex occurs when y is 0. When y is 0, x equals minus 3. So this is the vertex of the parabola right over here at minus 3, and the parabola opens to the right like this and like this. And so the region whose area we're trying to find is what I'm shading in right now. This is the region whose area we want to compute. This is minus 3. That's 1. And we need to find the points of intersection of the parabola and the line. These 2 points are crucial in the computation of the area. So to find those points of intersection, we plug in x minus 1 for y into the parabola. So x minus 1 quantity squared equals 2x plus 6. This is x squared minus 2x plus 1 equals 2x plus 6. Moving everything to the left, x squared minus 4x minus 5 equals 0, and this factors into x minus 5 times x plus 1 equals 0. We find that x equals minus 1 and 5. So the first point has the x coordinate right over here, minus 1. And at this point, if I drop down, has the x coordinate 5. Now, to find the y coordinates, we plug in minus 1 either into the line or into a parabola. That's minus 1 for x, and solve for y. When x equals to minus 1, we can see that from the line y equals minus 2. So this point here on the y-axis is minus 2. When x equals 5, y equals to 4. So we have our region completely determined. And now we're going to proceed to find its area using integration. So let me redraw this region one more time. And the line goes through like this, and the parabola goes through like this. Now we can integrate first with respect to x, and then we're going to find the very same area by integrating with respect to y. Each type of integration offers interesting solution, and you have to decide which solution you like best. So this point here is minus 1. Now, as we can see, the area can be divided into 2 parts. The L, which is the left part, and R, which is the right part. Now, on the left side, the top portion of the graph, the top border, is the upper parabola, and the bottom border is the lower parabola. And on the right side, the top part of the area is the upper parabola. The lower part is the line. So we take y squared equals to 2x plus 6. Solve for y. Y will equal to plus or minus the square root of 2x plus 6. the upper parabola right over here, that's y equals to positive square root of 2x plus 6. And the lower portion of the parabola is the negative square root of 2x plus 6. So the area of this region is computed as follows. First, the area of the left region. It is the integral, this is minus 3. It is the integral from minus 3 to minus 1. The top portion, which is the upper parabola, 2x, square root of 2x plus 6, minus the lower border, and that's the lower parabola, negative square root of 2x plus 6. Note that this is not 0 because the area is not 0. This difference is not 0. Plus the area of the right region, that's the integral from minus 1 to 5. Upper parabola on tops, that's square root of 2x plus 6 minus the line. Make sure you put it in parentheses so as not to make any mistakes. And so all we have to do is evaluate these two integrals, and we're going to have our area. So the first integral, because the two functions are essentially the same, becomes 2 times the integral from minus 3 to minus 1 times the square root of 2x plus 6 dx, plus the integral from minus 1 to 5 square root of 2x plus 6 dx, minus the integral from minus 1 to 5 x minus 1 dx. So first we're going to integrate the radical. We're going to let u equal to 2x plus 6. When x equals to minus 3, u becomes 0. When x equals minus 1, u becomes 4. And when x equals to 5, u becomes 16. du becomes 2 dx, and so 1/2 du is going to replace dx. Now the first integral, we have a 2 times the integral when x is minus 3 to minus 1, that's u is between 0 and 4. Square root of 2x plus 6 becomes square root of u, and dx is 1/2 du, so this is 1/2 times the square root of u du, plus the same integral, except there is no 2 in front. When x equals to minus 1, u is 4, so this is the integral from 4. When x equals 5, u is 16 times the square root of u, and then 1/2 du replaces dx, plus or minus the integral of x is 1/2 x squared. The integral of 1 is x, and this is evaluated from minus 1 to 5. Now the integral of square root of u is 2/3 u to the 3/2. So the first integral becomes the 2 and the 1/2 cancel, so we just have 2/3 u to the 3/2 evaluated from 0 to 4, plus 1/2 times 2/3 u to the 3/2 evaluated from 4 to 16, and then minus 1/2 x squared minus x evaluated from minus 1 to 5. Let's see what this equals to. Here plugging in 4, square root of 4 is 2, 2 cubed is 8, so this is 16/3. Putting 0 in for you is 0. Over here 1/2 and 2 here cancel, so we get plus 1/3 times the quantity. Square root of 16 is 4, 4 cubed is 64. Square root of 4 is 2, and again 2 cubed is 8, so 64 minus 8. And then minus, plugging in 5, that's 25 over 2 minus 5 minus 1/2, and then minus a minus 1, that would be plus 1. So let's see what we end up with. 16/3, and then 64 minus 8 is 56, so this is plus 56/3 minus, and in the brackets we have 25/2 minus 1/2 is 24/2. Minus 5 minus 1 would be minus 6. So this is equal to 72/3. 24/2 is 12. 12 minus 6 is 6. So 72/3 minus 6. 72/3 is 24 minus 6. So the area of the region is 18 squared units. But there's another way to solve this problem. Instead of using multiple integrals and evaluating the left and the right region, we can use just one integral by integrating with respect to y. So I'm going to redraw the region again. This is our line, and this is our parabola. This time we're going to view things from the point of view of variable y. So we want to know the y-coordinate of this point of intersection. That, of course, is minus 2. And the y-coordinate of this point of intersection, this is 4. As you see, we entered the region through the parabola, and we always exited through the line. So all we have to do is solve for, we take the line, which is x minus 1, and solve for x. X equals to y plus 1. So this line right over here is x equal to y plus 1. The parabola is y squared equal to 2x plus 6. If we want to solve for x, 2x equals y squared minus 6. X equal to 1/2 y squared minus 3. So the parabola right over here, x is equal to 1/2 y squared minus 3. So now the very same area can be computed as follows. We're going to integrate from minus 2 to positive 4. Now on the right hand side of the region we always have the line, which is y plus 1, and on the left hand side where we enter we have the parabola 1/2 y squared minus 3. And then we just integrate this with respect to y. Let me simplify this just a little bit. This is the integral from minus 2 to 4. We have minus 1/2 y squared plus y, and then 1 minus a minus 3 would be plus 4 dy. So this is minus 1/2 times 1/3 y cubed plus 1/2 y squared plus 4y, evaluated from minus 2 to 4. Let's plug 4 in. We get minus 64 over 6. 4 squared is 16 divided by 2, that's 8. 4 times 4 is 16. Minus, plugging in minus 2, so we get minus 8 divided by minus 6 would be positive 8 over 6. And then minus 2 squared is 4 divided by 2, that's 2. And then minus 8 right over here. So this is equal to, we have minus 64 over 6. Minus 8 over 6 is minus 72 over 6. 8 and 16 gives us 24. And then 2 and minus 8 is minus 6. So minus a minus is plus. So we have 24 and 6 is 30. 72 over 6 is 12 with a minus, that's minus 12. And once again we end up with the answer, which is 18 squared units. For more videos on calculus 1, 2, and other subjects, go to www.untitled math prep videos.com.